So they're telling us that g of x is the image after a bunch of things happen to the graph of f of x. Okay? There's a combination of transformations. There might be stretches, compressions, and translations. They've labeled corresponding points, so we know that A, something happens to it so that it goes to A prime, and B, something happens to it that it goes to B prime. So we can set things up with what we know. We know that on our red graph we have the point 0, 8. Something happens again, and we're going to end at -2, 0. A second point that we have is 2, -8. Something could happen again, and we're going to end up at 0, -8. Whoa. And in 3.3, we could have just looked at it and done it right away because there was only one thing that happened. But now that it's a couple of things that happen, maybe you get lucky, right? Maybe you decide, oh, nothing happens to y. Okay, so y is going to stay the same. Then I'm going to go down 8. That'll get me to 0. But if I do the same thing here, nothing happens, then I go down 8. Oh, it doesn't match. And you could be guessing and checking for a very, very long time. So this is why the other day I set you up with a second method that didn't work as good in the last one, but you're going to have to use it in this one. And that method was first to look at the horizontal and vertical distances. And you look on your red graph, what happens if I go from A to B? If I go from A to B, I go 2 to the right. So I'll write that as +2. And on my blue graph, if I go from A prime to B prime, can you see that that one also goes 2 to the right? Nothing changed, so you can say x by 1, or you can just say there is going to be no horizontal stretch or compression. It's going to stay the same. They still stay 2 apart. But when we get to our vertical distances, on our red graph from A to B, okay, and now A is up here at 8, and B is down here at -8. To go from A to B, I'm going to go down 16, so I would write that as a -16. From A prime to B prime on my blue graph, I go from 0 down to 8, so I go down -8. Putting those together, can you see that your y values have been multiplied by a half? You can now transfer this information up here. The only thing that is going to affect this first arrow is y gets multiplied by half. I mean, you could write x by 1, and if you really want to practice your 1 times table, that's great. It's like 1 times 2. Still got it, right? And 1 times 0. Yes. Okay, if you know, but y by half, that's going to be 4 and -4. And when you only have one arrow left to do, now it becomes easy. How could you possibly go from 0 to -2 with a translation? You would have to subtract, which would mean you'd go left 2. Does it work for the other one as well? It does. What could you possibly do to go from 4 to 0? subtract 4. So we're going to go down 4. Does that work for the other one as well? It does. And now you have those information above those arrows. Okay. Write and verify an equation for the image graph in terms of the function f. So we need an equation y equals, in terms of f, y by 1/2 would be in front of the function. Anything inside the function? Yes, we're going left 2, x plus 2 inside the function, and finally down 4 outside of the function. It says to write and then verify. Verifying would be doing these, we could just go, okay, let's check. If I go 0, 8, and I do y by 1/2, left 2 down, it seems kind of redundant because we did this already, but if you check it, sure enough, 0, 4, and then -2, 0, it works. And you could verify it that way. But I think if I did this work and it said verify, I would just go verification. ... Oh, done. And then rather than rewriting it. Okay. So this technique of looking at horizontal and vertical distances will tell you what kind of stretches and compressions happened. Because that stretch or compression is going to happen no matter what. If you shift it around afterwards, it's still going to appear. So that's how this part works. And once you have that part, plugging it in above your first arrow, you can get your next intermediate points without even having to graph it. And then it's easy to find the last bit of how it's moved. Okay? Some things to be careful on. Don't just count the distance between 2 points. Notice that I wrote A to B was -16 because we went down. Because I think on the one that I'm going to give you for homework, one goes down, one goes up. So there's a reflection also involved. Okay, so try question number 9.